So this is my PCB working. When I flick these switches, the voltage goes to half, then 3/4, then 7/8, and so on, until it caps at about 7 volts due to rail-to-rail voltage swing. So this is my R2R DAC ladder circuit. So we have a switch bank here for the inputs, a resistor network connected to ground so there's no floating current, and then finally the ladder itself. This is my R2R digital to analog conversion ladder. I'm using 1K and 2K resistors here, but any resistors are fine as long as the resistors in the place of the 2K resistors here is twice the resistance as the resistors in the place of the 1K resistors. The total resistance of the circuit is whatever resistance is here. Due to Thevenin's theorem, we can cut the circuit off at any point, for example here. Because we have 2K and 2K in parallel, we have 1K. And then because we have 1K and 1K in series, we have 2K again. And then because it's 2K and 2K in parallel again, we have 1K. And if we repeat this a couple more times, we end up with a circuit like this. So for the voltage of the leftmost branch, we'll set the voltage as V. And we have two 2K resistors going from voltage source to ground. So in the middle, it will be voltage over 2. And then because this is 1K and 1K, it's 2K again, and then it will be the same thing. So for the next one, it will be voltage over 4. And all the way until the end, if we repeat this a couple more times, it will just become like this. And voltage will be voltage over 256. And because for each of the branch that we move to the right, it experiences one less intersection, so the voltage will double for each branch that we go to the right, and we have something like this as a result. This is my breadboard prototype working with the op-amp. When I flick these switches on one by one, the voltage goes to 1, 3, 7, and then so on until 255 out of 256. And it goes until it caps at 6.3 volts due to row-to-row voltage swing. So this is the operational amplifier. In this case, we're using it as a voltage follower. Basically, it wants its two inputs to be in the same in voltage. So if we put it at the end of our circuit here, it will keep the voltage from the circuit, but because the inverting input is connected to the output, it will amplify the current. You can see here in two circuit diagrams, in a circuit with the op-amp, the LED shines a lot brighter than in one where there is no op-amp.